Okay, so we're now moving on to lesson 5, which is the position time graph. Hopefully you're getting comfortable with when we do position time graph, you were using Khan Academy and you have a little bit of background. And so we're going to try to plot them using graphs and the graphical techniques that we talked about. Okay, so we have, so I'm going to use Cami. I've never tried teaching with Cami, so we're going to see how that goes. Okay, so we got a card that is going from one end to the row to the other. They are giving you the position time graph information. I think I'm just going to zoom in a little bit. Okay, so every time when you're doing a position time graph, if you remember, oh, this is the title. So I still would like you to write the title, like follow all the format. Okay, so the title is, this is called the position versus time graph. Okay, I would put my name and I would put today's date. Today is September 16 for me. Okay, and keep in mind that the time is always the x-axis and the position is always the y-axis. So I'm going to zoom out a little bit. Okay, so I need to create my axes. So I'm just going to use a line shape, and I'm going to change my color. I don't know how to change. Okay, I'm just going to change my color to turquoise. Okay, so I know that my x-axis starts from the 0. I'm just going to draw a line straight across. Okay, I think I should change the color, the thickness a little bit. Okay, I'm just going to change the thickness of the line a little bit so we can see the axes a bit better. So the axes are going along the x, okay? And then I have the axes that are going along the y. And I'm just making a straight line tools, okay? So, and then I'm going to start using my drawing tools and I'm just drawing my ticks, okay? I'm keeping it as 2. So take a look at the time first. I'm going to do the x-axis first. So the x-axis, my time goes from 0 to 8. Okay, so 0 is at the bottom. Okay, so I'm actually just going to use every 4 box is 1. Because that fits all the way up to the 8. Okay, and the other thing that I have to do is I have to label my axes. So I'm going to say time is measure. I'm going to go back up and check. Time is in seconds. Okay, then the next thing now is I'm going to do my y-axis. My y-axis has to go up to 32. I'm going to have to count the boxes. Okay, they're really nice. They actually gave it up all the way to 32. So this is probably a bit too easy, but every tick is 1. Okay, so this is 5, 10, 15, 20, 25, 30, and it goes all the way up to 32. And then I'm going to label my axes, position, and don't forget your unit and the direction that goes with it. Okay, now you're going to put in your points. I'm going to use yellow. I'm going to change color, and we're going to do a point. I'm going to make it slightly thicker. I'm going to make it a 6. Okay, 0, 0. So I put a dot nice and clear at 0, 0. At 1 second, I go up to 4. At 2 seconds, I go up to 8. So this is a position time graph. So this object is moving every 1 second. At 1 second, I'm at 4. At 2 seconds, I'm at 8. At 3 seconds, I'm at 12. Does it make sense that this object is actually going at a constant velocity? So the same time increment, I am going the same amount of distance. So I have to be going at a constant velocity, right? So 4 is 16. 5 is 20. 6 is 24. 7 is 28. And 8 is 32. Oh, yeah, 32. Okay. So I've drawn. So right now, how does the mark goes? Okay, I'm going to use a red pen, not as thick. I'm just going to change to line 2. You get 1 mark for the title. Well, actually half a mark for the title, half a mark for the name and date, half a mark for labeling and labeling the axes as well as drawing the tick mark and the number, half a mark for the x-axis. Okay, you get 2 marks for putting in the dots. 1, 2, 3, 4. The final mark, graphs are always at a 5. The final mark is your line of best fit. Okay, so you can freehand it if you want, but if there's a shape option, why not use the shape option? So I'm going to go to shape. I'm going to click the insert line, and I would like my, I don't know, I'm going to use purple. And I'm going to start from, I might not make it as thick. I'm just going to make it a 4. And I'm just going to start a line, and I'm going to draw a line, and I'm going to let go. Okay, so that is my line of best fits, and that is your 5th mark. Okay, your final mark is the line of best fit, so that's out of 5. Okay, easy mark if you're able to follow instructions. Make it big, right? Make it try to fit the whole page. Oh, we get so far. Okay, and they're asking you to describe the motion of the car in your own words. Okay, so I'm going to leave this open. And we already talked about it, right? For equal distance, it is going at the equal length. So the answer to this is that it's traveling at a constant velocity. So I need you to fill it in. Oops. So fill it in. Describe the motion of your car. Every time when we're describing the motions, there are 2 parts. You have to include the directions. I'm just going to put in drawing. Okay, so every time when they ask you to describe the motion, you either say, is it stationary, meaning is it moving? Is it going at a constant velocity? Is it accelerating, meaning it's speeding up, going faster and faster as you go? Or is it, I'm running out of room, or decelerating? I would like you to write this down because these are the choices, right? So that's half of it. The other half of it, you have to include the direction. Okay, so those are the 2 parts that you need to include every time when they say, can you describe the motion of something? Okay, you're to describe how it's moving and what direction it's going. So in this particular case, it's going at a constant velocity because it's every 1 second I go 4 meters and then it's going at east. The next one asks you, how can you tell the car was moving at a constant velocity by looking at a position time graph? So if I go back to look at this position time graph, if I say, like, if there's no numbers, no letter, and I say, how is this graph looking like? You would say that it's a straight diagonal line. Okay, so this is a straight line. Ooh. So it's a straight line. Okay, so part C. So that means every time from now on, if I see a graph that looks like this, if I see a position time graph that looks like this, or that looks like this, it is going at a constant velocity. Okay, but one is traveling forward and one is traveling backwards. Okay, and they're asking you, what is the displacement at 6.5? So we go up to 6.5 seconds and we're trying to extrapolate the information. Okay, 6.5, I'm going to scribble a little bit. I can always erase. So 6.5 is right here. So I'm going to go up to 6.5 and I'm going to go across and take a look. So it looks like it is at 26. Oops. So this is now at 26 east. Okay. They're asking you to calculate the slope. We're going to go through how to calculate the slope right at the top. I know I gave you the answers, 4 meters per second east. Okay, but we're still going to go through it together. Okay, whenever you do a slope, you pick 2 points on the graph. It doesn't matter which 2 points because the way that is rising should be constant. So if I am, you can pick 2 points. I just like picking 2 points that are easy. You always want to pick things that are right on the grid. Okay, let's do this. Okay, I'm going to use blue. The equation, show your work. It's y2 minus y1 over x2 minus x1, right? You erase the other ones. That's the equation. You have to find 2 points, 2 and 1. Okay, I'm so sorry. y2 minus y1. Okay, you have to take 2 points. I always think if it touches 0, 0, that's the easiest. I'm going to write the numbers here. Pick any point on it, right? So I'm just going to say pick this point. Okay, this point was a 7 and 28. You can pick any 2 points on your line. Okay, this is an easy one because every single dot lies on the graph. But if you actually do a real experiment and if there is any experimental error, it might not lie right on the line. You have to pick things on your line of best fit. You always pick your 2 points right on the fit, okay? Okay, so if we're unsure about the slope, we're going to go slow, okay? This is point number 1. This is point number 2. What that means is, for point number 1, this is my x1 and this is my y1. For point number 2, this is my x2, the second point, and the y2. So plug in the equation. Y2 is 28 minus y1, which is 0, divided by x2, which is 7, minus 0, which is x1. So 28 divided by 7 is 4. The unit, I didn't put the unit down, I should have. We had, I'm just going to change it. I'm going to put in my unit. This is in meters. This is in seconds. Okay, so I have meters divided by seconds. So that's why it's meters per second. And we always include the direction. Okay, and we already talked about every second we go up by 4. This actually represents what is the velocity. We've actually calculated. Does it make sense? Remember, we already talked about the unit. Meters per second is velocity. So what they're indirectly telling you is if you have a position time graph and if you find the slope, it represents the velocity. And that's the next part of the loop. Okay, so we're done. We're done the 4. Are we okay? So we calculated the 4. And now this is the important lesson. If you're taking notes, if you're making study notes, I would totally write this. The slope of a position time graph represents the velocity. Okay. Number 2 is asking you describe the motion of an object. They're asking you to examine the other position time graph. And the first one asks you to describe the motion. So go back to up there, right? We were saying that there are different choices that you could put down. So it is a straight line. And we already talked about if it is a straight line, it has to be going in a constant velocity. The only thing that we didn't talk about is the direction. This is a little bit difficult. I don't know if you understand these, but I'm going to draw a straight line. And I'm going to just do a little number line, okay? And just, we're saying that if I'm just making this up, if I'm telling you that the object was at 200, do you see right at the beginning of trip at time 0, it is at 200. And this number line goes positive to the east. Okay, like whenever you look at this, they're telling you the direction. So positive to the east. And this is 0. They're telling you that this person started off at 200 and then take a look at the end of 8 seconds. Where is it? It is now standing at negative 200. I didn't even make the number line good. Can't see it again. Okay, so if I have this is 0, this is negative 200. At the end of the trip, he would have to travel this way to here. This is the D2, the final position. And if I'm asking you what direction he's going, we said positive is east. So if he's not going positive, he's going backward. Does it make sense that the direction should be west? Okay. So the answer that you should write down is that it should be traveling at a constant velocity at west. Remember the half and half thing, right? I said you have to write, is it stationary? Is it constant velocity or is it accelerating or decelerating? Okay. And then the directions. Second one is calculate velocity of the object. We already talked about at F. If the question asks for velocity, it's asking you to find the slope. Okay, so you need to know that because I'm not going to say, please find the velocity of the graph, meaning you need to calculate the slope. This is something you need to remember. Okay, you need to remember that to find velocity from a position time graph, I need slope. Okay, so that means you're going to calculate the slope. Okay, and then you can write the slope equation, y2 minus y1 over x2 minus x1. And you can write out the numbers, right? So pick any 2 points. Always like 0. If I have something that's 0, this is 4 seconds and 0. And you can pick any one. So I'm just going to pick this first point up here. So at 0 seconds, it is at 200. Okay. Which one is my 1 and my 2? Be careful. 1 is always the beginning of the time and 2 is always the later, right? And so let's work it out. So y2, so this is my x2, y2. This is my x1, y1. If slope is easy for you, you don't have to write all of these on the graph. Like you really could just write the 2 points coordinate, and then just plug it in. Okay, y2 is 0 minus y1, which is 200 in meters, divided by x2 is 4 minus x1 is 0, and they're measuring seconds. Okay, so negative 200 meters divided by 4 seconds. The answer is 50. Are we okay? This is 50 meters per second, and I got a negative. Is it negative east or negative west? Okay, we talked about that when we did lesson 3. This is whatever the calculation is, it is east, because this really is east, right? Like if you look at the axes, I put in the east. And if that's the case, negative 15 east really means positive 50 meters west. If you put this as an answer, I would accept it. But make sure you include the negative, right? Like if you put this as an answer, I would accept that. But this one obviously is better. So 1 mark for the equation, 1 mark for showing the work, and 1 mark for telling me the answer. So it's 3 marks question in this one, right? So don't just say 50. Like I need all the little information. Okay, last one. Now multiple sections. If you do a number line, sometimes it's easier for you to understand it. If I just I'm just going to do a quick number line here just so that I can visualize what the squirrel is doing. So this is where the object is. So it can go from 0, 1, 1, 2, 3, 4. And then it can go negative 1, negative 2, so on. Okay. So it tells me that I have a squirrel. Okay. The squirrel started at 0 second is at 0. So I have a squirrel that was here. Okay. This is the first position. And then travels to 4. Okay, this is my D2. And then from 4, he goes all the way to negative 2. So from 4, now he goes all the way to negative 2. Do you see how now negative 2 is the D3, the third position? Okay, finally, what did they do? Okay, what is this? What is this part? What is going on between 2.5 seconds to 4 seconds? I stay at 2. Do you see the segment that is horizontal line? He didn't move anywhere. He stayed at negative 2 the whole time until 4 seconds is up. So at this point, are we okay that if say that this is a stationary stage? We didn't really talk about it, but he didn't move anywhere. He stayed at 4. And then finally, he's now moving to 5. At 5 seconds, he's now moving back to 0. So finally, after the squirrel stay there, do whatever the business, come back to 0. This is the final position. Okay, so now let's talk about the motion. Whenever they have 4 sections, so this question would like you to describe the motion of the squirrel. When they're in segment like that, you need to describe the motion using the different segments. So I'm going to label them A, B, C, and D. And at each segment, you have to write what it's doing and what direction. A, B, C, D. I'm going to add to the picture. Anything, because I see the east, meaning anything to the right-hand side is the east. Okay? So part A, we said it was from 0 to 4. So he moved towards the positive direction. And because this is a straight line, he's going at a constant velocity at a direction of east. Part B now goes from 4 all the way to negative 2. Okay, I'm still traveling at a straight line. This is still a straight line. So similar to this last question, it is still, when it's still a straight line like this, it is still going at a constant velocity. We will be talking about when it's not a straight line, okay? So whenever it's a straight line on a dt curve, it is still a constant velocity. And when it's a constant velocity, I need to find the direction. This is going backwards because we say, right? We said it's going from 4 back to -2. So this is traveling to the west direction. Part C, it stay at the position of -2 the whole time. So he's not moving anywhere. So I'm going to write stationary. And when it's stationary, there's no direction. And finally, D is a tricky one in terms of direction. D is still a straight line, so it's still a constant velocity. But which direction? It looks really complicated because it's a negative. Go back to your number line. I was standing at -2. I am now traveling to 0. I'm going to the right-hand side direction. I am actually traveling east. Okay? So the last question is determine velocity. What do I need to find from the graph to find velocity? I've asked you this. I've talked about it so many times. What do? We calculate the slope. I don't like that. I'm talking to myself. It's funny. It's like making, I don't know. Anyway, all right. So I need to find the slope. I'm going to clean up this a little bit just to make it a bit clean. I'm going to take these guys out that I don't need. Okay. I'm still leaving the segment the segment, but I'm now going to find the slope. Okay. So to find the slope, so I'm going to have to do it for all 4 segments. So A, B, C, and D. Okay. Part A, I'm only going to write the equation out one time just because they're all the same. Okay, y2 minus y1 over x2 minus x1. And I'm going to pick 2 points. I like the 0, 0. So on for line A, and I'm going to pick this. This is 1 and 4. So find the slope. Y2 minus y1, 4 minus 0. So this equals to 4 meters minus 0 over x1 is 1 minus 0, 1 seconds minus 0. So 4 minus 0 is 4, 1 minus 0 is 1. I conveniently made it so that I'm minusing 0. Okay, whatever you get is always east. If it's negative, you swap it to the west. Okay, part B, I picked 2 points. I'm going to use the same 1 and 4. Okay, I'm just going to change color. I'm going to use this point, and I'm going to use this point. I just thought those were easy. No, actually, this is easier, but it doesn't matter. Okay. Oh. Still going to use the 0.14, and then I'm going to also use this point that is 2 and 0 to calculate the slope. The slope is y2, so I'm going to do in part B, right? So y2 minus y1 over x2 minus x1. So remember, this is 1 and this is 2 now, right? So the later time is always the 2. So 0 minus 4 is minus 4. 2 minus 1 is 1. So minus 4 meters per second. East or west? It's east. Whatever calculations you've done, it's always going to be the same as the one you chose in the axes. But if you would like to change it to the proper, it really should be a positive 4 going to the west direction. Okay, part C asks for what's a velocity at C. The C is a horizontal line going sideways like that. The slope of a horizontal line is 0. So you really could just be doing 0. If you wanted to do the math, you do the math, x2 minus x1, and do the math. It should still work out to be a 0. Okay, last one, part D. Okay, I'm just going to do it over here. So for part D, I picked 2 points again. So the first point is right here. I'm going to say this is 4 seconds and -2. And then for this point up here, it's 5 seconds and it's 0. So 1 and 2, do your slope. M equals to y2, 0, minus y1. Be careful. Y1 is the negative, so I'm minusing a negative number. Is actually a positive now. Divided by x2 minus x1. So 0 plus 2 over 5 minus 4, which is 1. So 2 meters per second to the east. Okay?